Welcome to Lesson 9, the text processing trinity that separates senior engineers from junior ones. Linux is text, logs, configs, CSVs, JSON, source code, and three tools handle 95% of everything you'll ever do with that text. grep finds lines, sed transforms streams, awk works with columns. The trick isn't knowing all three, it's knowing which one fits the shape of your data. So log analysis takes 30 seconds instead of a 30-minute Python script. First up, grep, the line finder. The mental model is dead simple. Feed it a pattern, get back the matching lines. But the power lives in the flags. -I kills case sensitivity, -R walks a whole directory tree, -V inverts the match to find what isn't there, and -A, B, or C give you context lines around each hit. Critical for reading stack traces. For Regex muscle, -E unlocks alternation with the pipe, and -P gives you full Perl-style shortcuts like \D for digits. Master these 12 invocations, and 95% of your log searches become reflex. Now here's the decision matrix that should live in your head. Same access.log, 3 tools, 7 tasks, and notice the pattern. grep wins at finding and counting lines, SED owns substitution and deletion, awk dominates anything involving columns or math. Look at that bottom row. Top 10 IPs in awk is one line. In grep, it's a pipe nightmare. The lesson is simple. Match the tool to the shape of the data. Lines, transforms, or columns. Pick accordingly. So let's zoom in on SED, your substitution workhorse. The pattern to burn into memory is RS pattern replacement. That single construct is 80% of real SED usage. Add G for global, I for case insensitive, and swap the / for a pipe when your replacement contains paths. Then there's I for in-place editing. And please use I back the first few times until you trust your regex. Round it out with /shash to delete lines and N with P to print specific ranges, and you've got find and replace at scale, completely effortless. Now awk, and this is where you stop reaching for Python. The mental model is simple. Every line is a record. Every record splits into fields you address as $1 through $NF. You write a pattern, you write an action in braces, and awk does the rest. Want the client IP from an access log? Print $1. The last field, whatever its position, $NF. Need a different separator like the colons in etc. pass UB? -F and you're done. That's the foundation. Fields, patterns, actions. And now the payoff. Watch what happens when you stop thinking of these as 3 separate tools. Top 10 IPs hammering you with 5 ASICs errors. Awk filters the column, sort and uniq count them. Head trims the list. Stripping comments from nginx.conf. One SED expression. Bulk renaming staging to prod across every YAML. Find plus SED, done. The rule lives at the bottom. Awk for columns, grep for lines, SED for transforms. Pick the tool per stage, and one-liners replace entire scripts. Here's the glue that makes all 3 tools click together. Regex. But there are 3 flavors, and knowing which one you're in saves hours of debugging. Basic Regex is the default in grep and SED, and it's painful. You escape plus, ? Even parentheses. That's why most senior engineers reach for -E immediately. Extended Regex gives you clean alternation, quantifiers, and groups without the \zoo. And when you need look ahead, look behind, or shortcuts like \D, that's Perl Regex territory. grep-P or peak regrep. SED and awk don't speak it, so plan accordingly. Master these 12 patterns once, and every log file stops looking cryptic. So why does this 40-year-old Trinity still beat modern tools in 2026? 3 reasons. First, ubiquity. Grep, SED, and awk are on every Linux box, every Docker image, every ancient server you SSH into at 2 a.m. No pip install, no version drift. Second, composability. Each does one thing well, and Unix pipes let you chain them into pipelines that read like sentences. And third, raw speed on huge files. While Python Pandas loads a 50 gig log into RAM, and crashes, awk streams it line by line and finishes in 30 seconds. Always available, always composable, always fast. Now here's the payoff. 12 patterns that cover 90% of the text work you'll ever do. Print this page, pin it next to your monitor, and just use it. 4 grep recipes for finding, 3 SYD recipes for editing, and 5 awk recipes for columns and aggregation. Notice the shape of each pattern matches the shape of the data. Lines for grep, streams for SYD, columns for awk. After a month of writing real pipelines against real logs, you won't need this sheet anymore. It'll be in your fingers. Reading patterns is one thing. Burning them into your fingers is another. So here are 3 drills, 30 to 45 minutes total, and they're not optional if you actually want this to stick. Drill 1. 10 minutes pounding grep flags against a real log on your machine. Drill 2. 15 minutes with CD, and pay attention to the -i.back workflow. That backup file has saved senior engineers from career-defining mistakes. Drill 3. 15 minutes building an awk one-liner that counts unique values with an associative array. And honestly, that single pattern is what separates junior from senior shell skills. Now, the 5 mistakes that bite everyone at least once. First, 5 cascaded pipes when one awk wins. If you're piping grep into cut into sort into uniq, you're doing column work, and awk owns column work. Second, SysAdmin without .back. One typo in your regex and the file is gone, no undo. Third, regex flavor mismatch. \d is PCRE only. It silently matches nothing in default grep. Fourth, forgetting -f, so $1 returns the whole CSV line instead of the first field. And fifth, greedy .star eating from the first angle bracket to the last. Memorize the fix column. These are the bugs you stop shipping once you've seen them named. And that's the Trinity, mastered. Grep finds the lines, SYD transforms them, awk owns the columns, and you've got the decision matrix to pick the right one on instinct. Lesson 10 closes out the advanced stage with system, services, units, journals TL, the modern Linux init system. Same approach, real commands, real payoff, no fluff. See you in lesson 10.